This is a lesson on drawing statistical diagrams. In Sec 1, we have seen different types of statistical diagrams. We have the pictogram, the bar chart, pie chart, and the line graph. The first three types of graphs are used to represent categorical data, which means data which have many categories. Whereas for the line graph, it used to represent numerical data, which is only one type of data, in this case, the temperature. And it shows the relationship between the temperature and the time, the changes of the temperature over a period of time. We now take a look at more example of this kind of graph that represents numerical data. The first type of graph we want to look at is the dot diagram. And to draw a dot diagram, we must first take a look at the lowest value and the highest value, which is the range. The lowest being 18 and the highest is 30. So we draw a line ranging from 18 to 30. Make sure that the numbers are in running order and that is equally spaced. Right, so now what we do is we cross out the values and transfer it into a dot on the line. 20 and 22. We can do two numbers at one time. 21, 21. Don't do too many, or else it can be confusing. Alright, 18, 18. Then 30, 20. Make sure that the dots are about the same size and equally spaced out. 22, 23. And then 22, 20. Right, so now it is good to count the number of dots and make sure that the number of dots corresponds to the number of items. Here we have 2 times 6, 2, 4, 6. 2 times 6, 12. So there should be 12 dots. 3, 3, 6, 3, and 3, 6. Now let us take a look at how we describe a statistical diagram. We first need to give a short description of what the data is, and specify the range. So this data are the times taken for 12 employees to travel from their homes to office, and ranging from 18 minutes to 30 minutes. Then we need to specify the cluster, that means where most of the data lies, and the time taken is clustered group around 20 to 23 minutes. And if there are extreme values, like in this case here, there's an extreme value of 30. Then the distribution, this is called a distribution, is not symmetrical because you see that a lot of data is here. It's one-sided. Facts about dot diagrams. Dot diagrams are only suitable for a small set of numerical data because each dot represents a data value. So if there are too many data, then there will be too many dots and it will be not appropriate to draw such a diagram. So it is also not suitable for a data set with too many values. That means the range is too wide, then we have an extremely long line, which is not practical. Now we take a look at a histogram. A histogram looks like a bar chart. The difference is that a bar chart represents many categories. So the histogram only measures a single type of data. In this case, this is a score, and the number of items is represented by the frequency. Right? So the bar chart is separated by a space to separate the categories, but there are no spaces in the histogram. Let us now take a look at how we draw a histogram. Now, before we can draw a histogram from a raw set of data, we need to draw up a frequency table. Now, this histogram is for ungrouped data. That means there are no range of values. Now we do the tally. We cross out the value to keep track of it. 1, 2, 3, 4. So we have 4 5s. And then for the 4s, we have 1, 2, 3, 4, 5, 6, 7. So 4 is 1, 2, 3, 4, 5, 6, 7. Right? So as we cross, we keep count here using the tally. So I think we have 4 counts here. 4 counts. And 6, 2, 3, 4, 5, 6. And this one is 7. And this is 5. 1, 2, 3, 4, 5. Right, now we need to draw up on the table. Now for the ungrouped data, the values are in the middle of the bar. Okay, so the 0, 1, 2, 3, 4, and 5. And then for the vertical axis, the frequency maximum is 7. So we have 2, 4, 6, 8. Now we need to draw the bars. So the first bar is 4. Make sure that the bars are of equal width. Second bar is also 4. The third bar is 6. Then 5. 7. And 4. Right? This completes our histogram for ungrouped data, making sure that the number of purchases is in the middle of the bar for ungrouped data. Facts about histogram. Histograms can represent a large number of data. We know that dot diagram cannot represent that because there are too many dots, but now the frequency is represented by a bar, so we can represent a larger set of data. But it's more abstract because the frequency is represented by the area of a column. If the frequency does not start from 0, then the data may be misinterpreted. The next type of diagram is called the stem and leaf diagram. Again, we are drawing it from a raw data set. Once again, before we begin, we will have to take a look at the range, that is the lowest value and the highest value. Lowest value being 12, the highest value being 65. For a stem and leaf, what we are doing is we are separating the digits from the tens unit in this case. So the digits are the leaves and the tens are the stem. The lowest stem is 1. 2, 3, 4, 5, and 6. Well, because we need to arrange the leaves in the order of smallest to the biggest, therefore it's good to draw a rough diagram first. Right, so now we have 20, 33, 20, 33, 30, 59, 30, 59. Okay, 14, 41, 14, and 41. Right, so we cross and then we transfer it here. So here we have 2, 9, 3, 8, 2, 7, 5, 5, 0, then 1, 4, 1, and 9, 6, 6, then 2, 5. Right, so now we can rearrange them. Smallest first, 2, 4, 9. And this one is 0, 2, 3. Make sure the numbers are in line. Okay, 3, 0, 0. And well, we can cancel so that we can keep track. 0, 0, 3, 5, 5, 7, 3, 5, 5, 7. And we have 4, 1, 1, 4, and 6, 6, 9, then 2, 5. Right? So now the numbers are in running order. Right, now it is important now to take note of how many are there. Here we have 3 times 7, which is 21 numbers. So we must have 21 numbers here. Right, so we have 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay. Now, it is important to write the key that gives meaning to this stem and leaf. For example, 4 stroke 1, 4 slash 1, in this case, means 41. Right? Whenever we read a stem and leaf, we always read the stem first. So we should read this as 12, 14, 19, 20, 22, 23, and 28. Now, a class interval is the range of values. For example, the class interval here is from 30 to 37. The class interval here, 41 to 44, and 56 to 59. So there are 6 class intervals. And the class intervals with the lowest frequency, the least number, is this class interval, which is 62 to 65. Now, if a stem and leaf is too long, too many values in one line, we can actually split the stem. So when we split the stem, the first stem will be ranging from 0 to 4, and the second stem is from 5 to 9. Okay, so this stem here, 2 to 4 will go up to the first stem, and 7 goes to the second stem. Right, here numbers from 1 to 3, right, goes to the first stem. 5 onwards go to the second stem. The second stem is from 5 to 9. This is only done when the stem and leaf gets too long. So normally we don't do it if the stem and leaf is a short number of data. Now we take a look at another type of stem and leaf. This is called a back-to-back stem and leaf. That means there are two stem and leaf in one diagram. In this stem and leaf, it is used to compare the lengths of terrapin from two different habitats. Terrapins are tortoise-like animals, and habitats are the places they live in. Right, so there are two habitats, habitat A and habitat B. So those terrapins that lives in habitat A has different lengths, body lengths, with those in habitat B. And in this case here, the key 5/0 means 5.0 cm. So 6/2 is 6.2 cm. Notice that in the other stem and leaf for habitat B, the stem is read in the reverse direction. So 4/5 means 5.4. Remember that we always read the stem first. So this is 5.4, 5.9, and again, make sure that the numbers are ranging from smallest to biggest from the stem. Facts about stem and leaf diagrams. Now, stem and leaf is suitable to represent data set which have many different values by grouping them into class intervals. The individual data values are retained as leaves, so every data is counted. And we can also display two sets of data in one diagram using a back-to-back, and this is used for comparison. It's tedious to construct a stem and leaf, and it cannot group data which is across the class intervals because of the stem. Now we take a look at a histogram for group data. Group data are data that are grouped together. For example, height from 140 to 150 is grouped together, so there is a range of values. Okay, so again, first we have to draw up the tally, get the frequency, and this time round, you notice that the numbers are at the edge of the bar to show the range of values. It is not in the middle. So remember that for group data, the numbers are at the side of the bar, and for ungrouped, it's in the middle of the bar. Facts are for histogram for group data. Right now, so the advantages for histogram is suitable for displaying a set of data with many different values by grouping them into equal class intervals. In this case here, for group data, individual data is not important because they are grouped together, so we don't know how many of them of a certain type. It's easier to construct than stem and leaf, especially when there are too many data values. And it can be grouped into class intervals, which are across, not like the stem and leaf. It's more abstract as frequency is represented by the area of each column, and individual data values are lost. In summary, if we are grouping statistical value, we don't need to group when there are too many different values. The different type of statistical data, dot diagram meant for a small set, and histogram for ungrouped data is used for a large set of data. Stem and leaf, if you have data with too many different values, which can be grouped into class intervals, and we want to retain the individual data values. Histogram for group data, used to represent many different values, which are grouped in class intervals, but individual data are not important. And that concludes the lesson for drawing statistical diagrams.